Ahoy, 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 ahoy. Let's look at one final example of a category. So this time I would like you to think of your favorite preorder. So let's say that P and less than is a preorder, and it's important here that it really is propositional, meaning that if we have two proofs that x is smaller than y, then these proofs are actually equal. Right? And remember that preorder means that it's reflexive and transitive. Okay, so now if you give me that, then I'm going to give you a category constructed from this preorder. So the idea is that I'm going to take the objects of my category to be the elements of the carrier set. So I have some elements like this, and I'm going to say that there is a morphism from x to y exactly when x is smaller or equal to y. So it's going to look something like this, right? So we see that reflexive and transitive is exactly what we need in order to say that we have an identity morphism from every object that's reflexive, and transitive means that we can compose these two morphisms, right? So saying that this is true if x is more than or equal to y. So this in a way is another extreme of a category where we do have many objects, but we have at most one morphism between any two objects. Right? So that's what we said with the propositional. And we need this because otherwise we would have to ask for more coherence conditions. So let's see if we can do this. So here I defined what it means to be a preorder. So I have a carrier set, I have an order relation which is reflexive and transitive, and I've asked that it's also propositional. So if P and Q are proofs that x is smaller than y, then P is equal to Q. Okay, so let's see if we can do this. Well, I said that my objects should be the carrier set of P. Okay, so I need to actually open this preorder. Okay, and I said that I should have a morphism from x to y exactly when x is smaller or equal than y. Right, and I have to say that this comes from P. Okay, and then my identity should say, if you can read this with a parameter, it says that it should be proof that A is smaller or equal to A. Well, that's the fact that P is reflexive, right? And my composition says that if A is smaller than B, and if B is smaller than C, then A should be smaller than C. That's exactly transitivity of P. 8. And then associativity, well, it's talking about this transitivity proofs. So the fact that I asked for it to be propositional is exactly what I need. Right, and similarly, these two proofs are equations between proofs in the preorder. So I can just use sledgehammer or propositionality to get rid of this. And again, you could not ask for it to be propositional, but then you would need some coherence conditions for these things, which would make it look a lot like a category actually. So you see that this is not a special case. And if you think about it, this first example we had about discrete categories is actually an instance of this, right? Where the preorder is just given by equality, which indeed is reflexive and transitive. So this is a generalization of that example of discrete categories.